to Unit 10, Lesson 1 Prom. This is the difference of two proportions. So far, we have done one prop Z test and one sample T test. So now we're going to be comparing two populations, and we're going to find the difference of the proportions in those two populations. So open up your packet to junior, senior prom. Which grade is more likely to go to prom? Now, the publishers of Stats Medic are from Michigan, and most schools in the north do a junior senior prom. The school I went to in Ohio had a junior senior prom, so if you were a junior or a senior, you could go to the prom, by yourself or with a date or whatever. Obviously, at Dawson, we have only a senior prom, where you have to, if you go as a junior, you have to be the date of a senior. But that's the background of the junior senior prom, so let's go ahead and take a look at this. The student council at a large high school know that more seniors will attend prom. But how many more? A random sample of 45 seniors revealed that 29 are attending, while a random sample of 50 juniors revealed that 28 are attending. Construct a 95% confidence interval for the difference of proportions of seniors and juniors who are attending prom. So if you remember, before spring break, we did confidence intervals. So we're back to confidence intervals, but we're doing with two proportion, and we're comparing seniors to juniors. So first of all, let's go ahead, and we made a 2x2 table with seniors, juniors, yes and no, and we filled it out. And then we're gonna just fill out our basic information, which is proportion of seniors attending prom is 29 out of 45, and the proportion of juniors attending prom, which is 28 out of 50. The difference in proportion of seniors and juniors planning is P1 minus P2, which is 0.64 minus 0.56, and that's where I got the 0.08 from. So with the parameter, remember parameter, whenever I ask you to state the parameter, that is going to be in words. So now, since I'm doing the difference, it's P1 minus P2, and that's the true difference in proportions of attending the prom. So we're saying we found 8% in our sample, but P1 minus P2 is actually the truth of the population, not just in the sample, but the actual data. The confidence level that we're doing is 95% because it says 95% in our startup of our problem, and that's what we're just going to solve. So let's go ahead and solve this. And the name of the procedure is the two sample Z interval for P1 minus P2, or you'll see that I like to call it the two proportion Z interval. That's what I'll usually call it. The conditions. So the two conditions that we're checking is, first of all, random sample, and secondly, the large counts. So for random sample, it says in my startup that I had 50 random seniors and 45 random juniors. Excuse me, I said that backwards, 50 juniors and 45 seniors. For large counts, I have to check each sample. So this is, remember, NP has to be greater than 10, and so that's both of them. So that's going to be 45 juniors times 64%, 45 juniors times 36%. The 64%, that's what this is right here. Seniors, sorry, I said juniors. So this is the 45 seniors. So basically, I'm looking to make sure the seniors that are attending prom and the seniors that are not attending prom, both are going to be greater than or equal to 10. And then I'm going to do the same thing for the juniors. So you can see I had 50 juniors, and I have 56% of juniors attending prom, and I have 44% that are not attending prom, but all of these numbers are greater than 10. So that checks my conditions. So then we are set. Okay, so now if the conditions are met, we're going to perform the calculations, and you can use a two sample Z test. You can use, if you go to this website, it'll perform the applets, but I'm actually going to go ahead and show you here, and that's what you guys are going to do now, is how to do this by hand. All right, so the formula that you're going to be using by hand is going to be P1 hat minus P2 hat plus or minus Z star square root of P1 hat Q1 hat over N1 plus P2 hat Q2 hat over N2. Let me define these things for you. P1 hat is obviously, you know, X1 over N1. And for this one, you can see our P1 hat was 0.64. It's just, so this was 0.64. P2 hat, that's the proportion of juniors, and that's 0.56. Q1 hat, that's just 1 minus 0.64, so that's 0.36. Q2 hat is 1 minus 0.56, which is 0.44. And then N1 is how many seniors, and that was, let's go back up there to 45. And N2 was 50, because that's how many juniors. All right, so I'm going to go ahead and on the next part here, you can see the interval that it's getting, but we're going to actually, I'm going to show you actually how to do the interval. And remember to find Z star, you can put this on here. Z star, remember to find that. We did this if inverse norm, which is menu, stat, distribution, and it's inverse norm from there. And remember we have area because it's 95%. Remember I have 95% in the center. If you remember, we've done this before. That means I have 2.5% on each side. But if you recall, I have to go past the 2.5% to the 95%, and so that's 97.5%. So this is going to be 0.975. The mean is 0 and the standard deviation is 1. Okay, and if I put this in here, let's go ahead and show you what it looks like in the calculator. So menu, stat, distribution, inverse norm, 0.975, 0 and 1, and you get 1.96. So the Z star is 1.96. So let's put all this together. So I'm going to put everything into this formula, all these numbers, and it's a bit of a mess here. So let's see. Let me just open up a new page. Actually, let me just send this to a new page and let me open it up here. Okay. All right, so, okay, so we have P1 hat minus P2 hat plus or minus Z star square root P1 hat Q1 hat over N1 plus P2 hat Q2 hat over N2. Okay, P1 hat, we already determined, is 0.64 minus P2 hat is 0.56 plus or minus 1.96 because we found that with the Z star. Square root 0.64, 0.36 over N1 was 45 plus 0.56, I'm doing P2, I'm at P2, 0.44 over 50. All right, so at this point you can put this in your calculator. You can put it all together in your calculator. I'll show you kind of how it works. So in your calculator, if I do this, watch, if I just go 0.64 minus 0.56 plus, it doesn't do plus or minus, so you're going to have to use this 1.96 and then square root, and I put this under the square root. So I have 0.64 times 0.36 over 50 plus, and then another one of this, and then that's going to be 0.56 times 0.44 over 45. Make sure I got it right. Oh, I've switched them. The 45 is supposed to be this one, and the 50 is this one. Let me just double check and make sure that's right, because the 64%, let's go back to our original data. Yeah, 64% came from the total of 45 seniors, and the 56% came from the total of 50. Okay, and so then I put plus, and that's going to hit enter, and that's 0.27. So then I'm going to go up, and I'm going to copy it, go over, and I'm just going to change it to a minus sign. And minus, and then we go. So I've got negative 0.116 to 0.2765. So I have negative 0.116 to 0.2765. And if you see, that's exactly what we got here. So this is from negative 11% to 28%. So what that means is we're 95% confident that the interval between negative 11.2% and 28.1% captures the true difference in proportions of those attending prom, seniors minus juniors. So this particular one, make sure you guys get this formula. So let's write this formula down on here. Now, I know this, don't put all of this here. What I'm going to do is I'm just going to actually do this for you because I'm going to, let me just put the formulas for you that I want you to have. Okay, so we're going to, I want you to make sure that you have this formula, and the formula is going to be this, and that's going to be P1 hat minus P2 hat plus or minus Z star square root P1 hat Q1 hat over N1 plus P2 hat Q2 hat over N2. Remind yourself that Q1 is just 1 minus P1. All right? And Z star, remind yourself how to get Z star. Z star, remember, is just inverse norm. And the area is the center, is the tail plus the center. Okay, so for, again, so if it was a 90%, for instance, that's going to be 5%, that's going to be 5%. Remember what that means is my calculator starts from 0 and I need this value and this value. So you could put in 5% and that's going to get you the negative Z star value, or you could put in 95%, which is going to get the positive Z star value. So that's 0.95 because it's 5% plus 90%. And that's the Z star value. This is going to be the negative Z star value. So if you put in the negative, it's just going to get the negative of what you have here already. Okay, and then for this, of course, our steps that you did, really it's learning target number 4. And for that, we are doing, it's showing the state plan due. The word I like to use is panic, which is parameter, which you guys have already done. Parameter, of course, that's in words. It describes it in words. And then we do our assumptions and conditions, which is random sample and large sample size, which we did was all the NPs and NQs, greater than 10, all of them. Name the interval. Find the interval. And then C, P-A-N-I-C, is the conclusion. Okay? All right, it says calculate the interval using applet or calculator. You can use the calculator. I do like to show you guys this formula here. Use the formula. And then, of course, these are our conditions, which we talked about, the 2 conditions. And make sure you get all 1, 2, 3, 4. All has to be bigger than 10. Okay, let's look at this one. It says, would you like some candy? Okay, so this is saying construct and interpret a 90% confidence interval. And then, so we have, we're doing PN minus PF, where PN is the proportion of all subjects like these near the bowl of candy, and PF is the proportion. So notice I'm doing both of them. So I have to define both of them. So this is the true proportion of those that like candy near the bowl, and this is the proportion that's far. So to do a 2-sample t-interval, or I call it a 2-proportion z-interval, either way is fine. You can do either one. We check the count, we check random, and it says that it came from a random sample, both of them. You got to say both, from 2 groups of a random experiment, and large counts. And of course, I'm making sure that they are at least 10. So N, P, and Q, basically all the counts. So I have 39, I have 22, I have 24, and I have 37. All the groups are bigger than 10. That's the whole deal. Okay, so when I do this one, I have my p hat is 0.639 and 0.393, and then here we go. Here's my formula. That's p1 hat minus p2 hat. There's my z star, because it's 90%. So to do that, it's inverse norm, and that's area. Okay, for 90%, I have to 0.95, because remember, it's the center plus the tail. And the mean and standard deviation are 0 and 1. And then, of course, that's my P1 hat. And that's my N1. And that's my P2 hat. And that's my N2. They happen to have the same number of in the data. N1 and N2 happen to be the same in this particular one. Okay, so then we find my answer. And so that's between 10%, 10.2%, and 39%. And then I just say, here, my conclusion says we are 90% confident that the true interval captures the difference between the proportions. Okay, between 10.2 and 39% higher in P1 than P2. So P1 is the near rather than far. And do we have convincing evidence that they would like to eat it when nearby? And yes, because if it didn't have a difference, then I would have 0, because 0 would be, if there was no difference, then P1 minus P2 would equal 0. That would be no difference. And you can see that the difference is 0 is not contained in the interval. So we say there is a difference, and it's between 10 and 39% higher. All right, I hope that helped. And you guys have a wonderful day. Make sure you upload this, and we'll talk to you later. All right, bye-bye.